I had a student ask about this question, so I wanted to go over it on a video just so that more people could be helped. See if I have a brush size of 1, what does that look like? Okay. So, the question says prism J and prism K have the same volume. What is the width of prism K? So really we're just trying to find that right there. So the first thing I'm going to want to do is find the volume of J, and that's just going to be a rectangular prism. So I'm going to do 10 times 3 times 4, which is going to give me 120. Then I'm going to try and find the volume of K. This is a prism, right? I have a triangular base here. If I take any cross section, it'll also be triangular. So I do know that the base is also triangular. So I'm going to say that the volume of K is equal to big B times the height. And we know that big B is the area of the base. So that's 1/2 base times height. And then we have a problem here. This H and this H represent two very different things, so we don't want to say H here. If I look at this solid, I could also say this is the depth of the solid. So I'm going to replace this with, what's it get, the volume times the depth. So I'm going to go ahead and put D here. So now I have the volume of K is equal to big B, which is 1/2 the base times the height of the triangle, times the depth of the solid. So let's start making some substitutions here. I'm going to go ahead and redraw the triangle over here just so I can orientate it in a way that's easier to see. So now I'm looking at this face, and on that face I can see that this leg is 3 and this is W. Excuse me. So on this triangle I have a base of 3, so I'm going to have 1/2 times 3 times W, right, because I don't know what that is. So there's my base, my height, and then my overall depth is 10. So I'm going to have that. And then what I have to do here is also substitute in the volume of K must be 120 is equal to 1/2, 1/3, sorry, 1/2 of 3 times 10, which is 30 times W. So 120 is equal to 15W. And then I just need to know what 120 divided by 15 is. And I'll do that with a calculator. 120 divided by 15 is 8. So that would be our answer. And another way that you can look at this, let me do it in a different color really quick. So I have, I chose white, cool. Another way to look at it is when I have this solid here, I know, well, let's just put it up here. Let me see if I can erase. Oh, it's going to do that. It's not on Zoom. I know that if I draw another line out here and here, make this a right angle, I have a rectangular prism. So I can say, what would this width have to be to make a rectangular prism that's equal to that? Well, since I now have double that, and I know this one's 4, this one has to be 8, so I can cut it in half and get back to it. But I really wouldn't put too much stock in doing that just yet until you get a little more efficient at the original way I did it. But that is one other way to think about it. And up next we have this problem, and it says which expression represents the volume of the rectangular prism that is not occupied by the cylinder. So what that's saying is, let's call the rectangular prism X, and let's call the cylinder Y. So what it's saying is, what is the volume of X that is not occupied by the volume of Y? So the rectangular cylinder, the rectangular prism, and then we're going to take out the cylinder. Well, if it's not occupied, that means we're going to subtract the amount out. So I can say the volume of X minus the volume of Y is equal to the volume not occupied by the cylinder. So I guess one way to think about this is, let's say we're shipping this cylinder and we need to put some packing material in here to make sure it doesn't bounce around in the box. And we want to kind of know exactly how much packing material should we buy to fill this in so that the cylinder doesn't jostle around and get broken. So the first thing I need to do is find the volume of X, which is our rectangular prism. And to do that, the volume of X is equal to base times height times, well, let's do big B, little h, which then gives us 15 times 10 times h, because we don't know h yet. And then the volume of Y is equal to, well, again, big B times little h. We get pi r squared for this, because that is our base, a circle. So we have pi r squared times the height of the cylinder. Again, we don't know what the height of the cylinder or the box is yet. We just know they're the same height. So I can make a few substitutions in here. Pi never changes. Our radius is 5, so we're going to have 5 squared times the height. So now we need to set this up so that we have V, the volume of X, minus the volume of Y. So we know the volume of X, if I distribute this, is 150H. And then I know the volume of this is just 25 pi times H. Well, we don't actually have that answer here. We're going to say it's definitely not this. It's definitely not this. It's not this. And it's not this. But this one does look very similar. And I can see that the student picked this one, which is also extremely similar. One thing we have to do is kind of think back to Algebra 2, see if we can factor anything out. To be able to factor something out, we have to look at the parts that are separated by an operator. So here's our operator. And we're going to look at the left side of the operator and the right side and see what they have in common. Well, 150 and 25 both have 25 in common. But I can see in my answer choices, I'm still going to want to keep it at 150. So I'm not going to pull anything out of there. Then next I have pi. Well, this doesn't have pi in it, so I'm not going to mess with that. But they both do have an h, so I can factor that h out. And I'll be left with this h on the outside of 150 minus 25 pi. And that, by the commutative property, says I can move this h over here, or I can move it back here. So that is an equivalent answer, and that is our actual answer for this one. Alright guys, here's another question I was asked about. Before I do this one, I want to actually talk about what it's asking and talk about some keywords here that we can start to identify to help us with these types of problems in the future. So just reading the problem first, it says a candle maker adds lemon oil to wax to make the lemon scented candle shown below. How many ounces of oil will he need for the candle to have 25 10,000 ounces of oil per cubic centimeter of wax? So it wants it in cubic centimeters. So the first thing I'm going to do is verify that all my dimensions are given in centimeters. So we're good there. Then I'm going to look at this word right here. The word per means to multiply. And I'm only bringing that up because when we did this in the Zoom meetings today, we said let's divide right away, and then we got an absurd answer. And I'll show you that absurd answer after I show you the right answer. But anytime you see the word per, that means you're going to multiply the things that we're talking about together. In this case, we're talking about the ounces of oil per cubic centimeter. So when I find the number of cubic centimeters, I'm going to multiply it by that number. So the first thing I'm going to do is identify what the volume is. And I'm going to use big B times H, where big B is the length times the width, since we have a rectangular prism here. So we're going to end up with 8 times 10 times 25. So just doing this mentally, I know that this is the same as 4 times 2 times 25. And 4 times 25 is 100 times 2 is 200, and then I'm going to multiply that by 10 to get 2,000 cubic centimeters. So I'm going to go ahead and write that down. That is the total amount that this candle right here will fit or hold. I'm sorry, and the candle very reasonably will fit on your desktop at 10 centimeters by 8 centimeters by 25 centimeters. So we are going to put 2,000 cubic centimeters of wax into this candle, and we're going to do that at 0.0025 ounces of scented oil, lemon scented oil, per cubic centimeter. So to solve that, I'm going to take my information and know that the amount of oil I need is equal to the volume times 0.0025. So I'm going to do 2,000 times 0.0025. And if I put that into the calculator, 2,000 times, I get 5. So we need a total of 5 ounces of oil to make this a properly scented candle. Okay, let's look at what we tried. I'm going to section this off. This is my do not do. All right, so we've done this. We found the volume, and then we know that we need 0.0025 ounces of oil per. But I had a couple people say, let's divide. And let's look at what dividing actually does here. So let's see. 2,000 divided by that number gives me, put T for total, 800,000 ounces of scent. Okay. So if we had divided, we would find out that to fill this, or to get an appropriate scent from the candle, we would then think we need 800,000 ounces of scent. Well, if there's 16 ounces in a pound, you're looking at a 50,000 pound candle. Just in the scent alone. So any poor desk, tabletop, countertop that you set this candle on will be quickly obliterated. So be careful with that. Make sure your answer makes sense. 800,000 ounces is 50,000 pounds. There is no candle that you will put into your home in such a small container. The density of that, which is for a whole nother course, is outrageous. So be careful. Make sure your answers make sense before you put them in. But do everything you see in the light blue, red, orange, and dark blue. Completely learn from the mistakes of the purple.